Introduce Mirza Beg. Mirza is a lecturer, sustainability studies program here at Stony Brook University. Mr. Beg is an adjunct teaching faculty, an environmental geologist with expertise in water resource management, groundwater hydrology, sustainability, and energy. There's a diverse experience in academia, teaching undergraduate, graduate courses in Stony Brook University for over 20 years. Education and outreach. Mr. Beg has a double master's degree. Wow, that is impressive. In environmental management and geology. Using knowledge from a diploma in web development and business programming, he designed, developed, and taught courses in undergraduate studies at the University of Maryland College prior to joining SBU. Worked as an environmental education specialist for the Center of Environmental Molecular Sciences at Stony Brook University, National Science Foundation, and funded into the Interdisciplinary Center for several years, helping convey molecular science concept to students, teachers, and the layperson, obviously like me. Prior to teaching, Mr. Begg was an environmental scientist for an international consulting firm in Washington, D.C., being responsible for environmental business development, marketing, and coordination of projects to various clients, including the World Bank, U.S. Agency for International Development, USAID, Asian Development Bank, US EPA, and currently he's also the CEO and president of a newly formed company, Sukoon Sustainable Homes. So everyone, please, round of applause for Mr. Mirza Beg. Thank you.
Thank you for that wonderful introduction. All right, so here we are with that wonderful introduction by Dr. Gobler. He spoke about the impact of climate change and all that is happening over here and across the world. So this is a task that I have been given to speak in 40 minutes. It requires at least one semester, 4 months to talk about it, but I'll try to crunch it all together. All right, so to get your attention, can you do me a favor, please? Can you take out your cell phones and take a selfie? Take a selfie, please. Just take a selfie, like that. All right. Oh, yeah. Okay, yeah.
We're going to get a selfie like this. We'll go wide angle.
All right.
And if everyone could smile, you're all going to be an hour selfie.
All right.
There we go.
Great. Wonderful. Thank you. Thank you very much. All right. So having done that, let's get into this global climate change that is happening and also look at some of the solutions. So we'll talk about global as well, local issues that we are seeing with climate change. Now, what I'll do is I'll take you back in time. If imagine you are in a time machine, or you're all in time machine right now. I'll take you back 400 years from today. All right, imagine, close your eyes for a few seconds. Imagine you are 400 years back in time. Okay, what do you think where you are in time 400 years ago? All right, now open your eyes and tell me, what do you think was going on in the world 400 years ago? What has changed over 400 years? Anybody? Speak it out. Yeah? All right. So, well, I mean, 400 years, we did not have industrialization. We were still in the farming and that kind of small agricultural and small little tidbits of businesses here and there. And the world population was 1/10 of what we are today, right? So with the industrialization that has happened, climate has started to change rapidly. And that's what we are looking at now. So coming back in time, yes, you had a question. Thank you for that input. Yes, I mean, so things have changed over time. So now, what's the weather today like? Crappy, right? Weather. It's raining and all that stuff. Yeah. Well, okay. So what is climate? I mean, we see the weather. I mean, today, over a period of time, if you put all this weather together, like for a decade, for a century, or for a era, for a eon, or whatever, that is climate. Okay. So climate can be impacted uh, various different ways. There are natural ways of climate change. Okay. So, for example, solar activity like sunspots, they change from time to time. We've seen that happen. As a geologist, I can go back in record and look at all the ice cores, all the soil cores, and look in time how the climate has changed over time. All right. So there are all kinds of climate that has changed. We are in the fourth climate that we have since 4.6 billion years ago when the Earth and the universe formed. This is the fourth climate, the modern atmosphere that we have. And this is the most robust climate. All right. So climate does change. All right. These are natural sources like Milovic cycles, wherein you see glaciation and interglaciation, that is the warming and cooling periods. All right. So we are in the warming phase these days. Now, I'll ask you a question again, just to get input from you. Where you are sitting today, 12,000 years ago, what was here where you are sitting or where you live on Long Island? What was there? Can somebody tell me what was here? A mile thick ice glacier. Can you believe that? 12,000 years ago. All right. So that was a time when glacier was here and it was cold, intense cold climate. And it has changed. So if we see these are all natural phenomena, they are cyclic. Every 100,000, 200,000, 300,000 years, they go up and down. All right. So we've got glaciation and interglaciation, warming, cooling. Now, what has changed is the human interaction with the weather and with the climate. That is most important. That is what we have to understand. Most critical. All right. So human intervention with climate is the major contributor to climate change that we are talking today. All right. So yeah, we had industrial revolution in the 18th century, late 18th, 19th century, and then followed through in the last 50, 60 years, all the developing countries like the Indias and the Chinas of the world are trying to catch up and they are polluting. And that is what we are concerned about. Right? So this is where we are going. So all those greenhouse gases that are being emitted, like carbon dioxide, methane, water vapor is a greenhouse gas. All right? And that is all contributing to this modern climate change. And we are responsible, the smart ones are responsible for this. All right. So Earth is suffering from that kind of a action that humans have. Now, if you look at the greenhouse gases, I mentioned methane, I mentioned carbon dioxide, I mentioned water vapor. So we'll go through each one of these. All right. So these natural causes that we talk about, greenhouse gases are good for the earth. Now, when I say they're good for the earth, they are responsible for maintaining the temperatures that we have so that things can survive. All right. If there were no greenhouse gases, then the temperatures would have been all right. So here we are. Look at this cartoon here. The incoming radiation from the sun heats up our environment. Okay. And the 100 units that come through the atmosphere come to the surface of the earth, warms the surface of the earth, and those 100 units have to go back in the form of infrared and as well as long range UV. All right. So yes, I mean, all of these packets of energy that comes from the sun hits the surface of the earth and they have to go back. But if you place a hindrance enough for those packets of energy not to go out, re-radiate back into the space, then we are warming this earth. And all right, so let's see if we can run this video.
Awesome.
Okay. No, this is not the one.
Climate change will be ensured. Challenge accepted. Climate is the average weather for a place over many years. When the average weather shifts, that's climate change.
No. Before that.
Oh, the Google Drive. Apologies, that was my fault.
All right, so yeah, here is the animation. There's no sound here. Okay, so just to give you an idea of how this greenhouse effect works, right? I guess you might already know about it. So yeah, I mean, most of the heat is absorbed, and some of it gets radiated back again to this. Right? How do we go? Presentation. This one. All right. Okay. So climate change review. I mean, just. Oh my goodness. This is another video.
All the videos. Yeah. I warned you all I was a layperson before we got started with this talk. Would it be this one?
No. Yeah. Okay. Yeah. All right. This one. Okay. So yeah, I mean,
Extreme climate change will be ensured. Okay, challenge accepted. Climate is the average weather for a place over many years. When the average weather shifts, that's climate change. When sunlight hits Earth's surface, sun's absorbed and re-emitted as heat. Greenhouse gases like water vapor and CO2 absorb and re-emit that heat. And that's why Earth is habitable and not an ice cube. Greenhouse gases mean more heat is trapped and Earth gets warmer. Humans burning fossil fuels and changing how we farm and use land have increased the amount of CO2 in the atmosphere by 50% since the Industrial Revolution. Its average temperature is now about 1 degree higher than it was in 1900. Since 1971, we've added 4.5 Hiroshima atomic bombs of heat to the atmosphere every second. And 90% of that extra heat has gone into the oceans, causing rising sea levels and less snow and ice in the Arctic. If emissions continue like today, Earth would be 2 to 4 degrees warmer by 2100. And for humans and nature everywhere, that would be really, really bad. See, that wasn't so hard. Save this video in case somebody tells you.
Lemonade, pet, insurance. 3 words you've probably never heard used together. The drink, your best bud.
Sorry.
All right, so sorry about that interruption here about these videos. Okay, there are a few more videos, and I know you. Okay, so evidence of the climate change. I mean, we already talked about. As a geologist, we go back in time and look at what is it that we can find evidence from. Ice cores is where we go to. Okay, over a period of time, the ice that has accumulated in the Arctic, on the Alps and the Himalayas, and other ice sheets in Greenland and Antarctica and other places, we go and drill for that. And then we try to figure out at in time as what was happening in those. Also, in the ocean sediment cores, we look at again in time going back as to what was going on. And these are proxies. These proxies tell us a story at what was going on in that point in time. Okay. So yeah, also looking at the oxygen isotopes. Oxygen has two isotopes, I think probably most of you know, O16 and O18. O16 is the lighter one. As the water evaporates from the oceans, it goes and precipitates somewhere. And if the climate is warm, like in this case, in the top right corner, where there's no glaciation, the oxygen isotope O16 just runs off, doesn't accumulate. Whereas if the climate is colder, that same oxygen 16 isotope gets accumulated. All right. So yeah, we'll see this ice formation that would give us an idea as to when the climate was warm versus when the climate was cold. So yeah, that's how we try to recreate in historical terms when the climate changes. So those evidences are present, those proxies are present for us. As scientists, we can go and check them out. And so for the last 250 or 300 years since industrial revolution took place and industrialization is going on at rapid pace with the developing countries trying to catch up, we are seeing this change happening in real time, right? The ice in the icebergs is melting on ice sheets, it's melting on mountaintop, it's melting, and there's more runoff and more evaporation. Surface temperatures are increasing, both in the ocean as well as on the land. So these are all different evidences of modern day climate change. And I mentioned climate has changed over years, over eons. But this one is different. This is human caused, very rapid change. Something that used to take 200 to 250,000 years, 300,000 years for that climate on the natural basis to change has changed in 2.5 centuries. 2.5 centuries. And that is concerning. Right? So yeah. Now, I mentioned three things: carbon dioxide, methane, and water vapor. Let's look at the changes that have happened over the last 800 years. And I mentioned that as geologists, we can go and look at those ice cores and all those sediment at the bottom of the oceans. All right? And they give us an idea. So for the last 800 years, carbon dioxide is the maximum now, and it is increasing very rapidly. So this graph over here shows us that idea. And both the developing countries like China, India, Brazil, Mexico, Russia, South Africa, they are all contributing very rapidly to this change in carbon dioxide concentrations. So right now we are at 400 ppm plus of CO2 levels. All right. So yeah, having said that, if you look at this graph over here, CO2 levels are rising, and they're rising very rapidly since industrial revolution. And the point here is, for the 800,000 years, you see this CO2 levels going up and down, but they are within the envelope. We call it the envelope, the top and the bottom. They are within the envelope. But for now, if you look here at the extreme right, this envelope has been broken, and it's rapidly going up through the ceiling. It's going through the ceiling now. And that is what we are concerned about. All right. And you should be concerned about. All right. So yeah, let's take a look at this video if we can.
Oceanic Atmospheric Administration, or NOAA, found that greenhouse gases continued increasing in 2023. Levels of carbon dioxide, methane, and nitrous oxide all increased last year. Those are the three most common gases that, in excess, raise global temperatures by trapping too much heat in our atmosphere. But to drill down on carbon dioxide, the most abundant of the gases linked to global warming, it had its third largest increase in the last decade. Over 12 months, the average global surface concentration, or how much covered the Earth, was 419.3 parts per million. That is almost a 30% increase since 1980, time when the amount of carbon dioxide was still within levels defined by MIT scientists as ideal. Now, according to NOAA scientists, it has been around 4.3 million years since there was this much carbon dioxide in the atmosphere. Now, back then, sea levels were 75 feet higher than today, and large forests occupied areas of the Arctic that are now the wintry tundra we know today. Rising pollution levels contributed to last year's increase in the amount of carbon dioxide in the atmosphere. Carbon dioxide emissions reached 36.8 billion tons, a record level, according to the annual Global Carbon Budget Project. Scientists with the project describe emissions as being in a quote, temporary plateau instead of steeply dropping, which is needed to avoid climate disaster. Scientists partially attribute the plateau to the level of progress by different countries. For example, emissions increased in India and China, but declined a bit in the EU and US. For the other two greenhouse gases that raise global temperatures, methane and nitrous oxide, those scientists continue.
Thank you very much. All right. So similarly, we have methane going up. Again, for the 800,000 years, the records tell us that methane levels are the maximum that we have seen. So methane comes out again from industrial exhaust, from livestock and other actions that we do from vegetation and other places. Again, there's this rapid increase that you see here. I mean, with the methane levels going up rapidly. And again, this is cause of concern, I mean, for us. Maybe if we can run this video one more time.
I'm so sorry. You're the person for this.
Okay. We gotta pull that. It's all right.
Why is it important? Methane is a greenhouse gas mainly emitted from dump sites, oil and gas wells, coal mines, wetlands, and cowbirds. What you may not know is that methane emissions are the second largest contributor to climate change. They make up about 30% of the net warming impact of all greenhouse gases. In fact, when it comes to heating the planet, methane is over 84 times more potent than carbon dioxide. While there are many natural sources of methane, 60% of it comes from human activity.
I know. It sounds bad, but hang on. There's a silver lining. While methane may be more harmful than other gases, it doesn't last so long in the atmosphere. Compared to CO2, which lingers for centuries, methane stays in the atmosphere for about 12 years. So reducing methane emissions can help reduce temperature increases in the short term, while we work on longer-term climate solutions. Let's make that solution.
All right. So similarly, there's the water vapor. The more temperature increases, the more water evaporates. The more water evaporates, the more precipitation. And Dr. Gobler had given you a very good idea as to what is happening, what we are seeing in Northeast. All right. So yeah, this cycle goes on and on and on, and that's what is concerning us. Okay. All right. So methane and carbon dioxide, they are both cyclically increasing. However, they have gone beyond that envelope that I was talking about. And the temperatures are also rising in tandem. Okay. So yeah, I mean, that's something to be concerned about. I'll just skip this. So yeah, carbon dioxide can be absorbed by oceans. They are the sinks that can also be absorbed by the vegetation, the forests. We are deforesting. We are adding more and more carbon dioxide that cannot be absorbed. There's a limit to oceans. So there's ocean acidification, and that is harming the algae, the shellfish, and everything else that is out there. Now, with the sea level rise that we are seeing, I mean, our own Long Island coastal areas will be inundated. By the turn of the century, there'll be like a 1 meter rise of sea level, and anybody who lives in the coastal areas of Long Island, you will be impacted. I'll be impacted. So is the story with other places. All right. So with this extreme weather that we are seeing that is being changed, is also going to impact our health. Okay. So along with all that shellfish being impacted, all those corals being impacted, our human health will also be impacted. Food chain supply would be impacted. All right. That is all related, interrelated. So agriculture production will change over time with this climate change. Okay. There'll be loss of agricultural land. There'll be loss of productivity of food. So there's all kinds of issues involved with it. Human health will be impacted. We'll see if anybody has asthma, they will be having more deleterious issues with their health. If anybody has any kind of other diseases, they will be much more exacerbated with the high temperatures that we are seeing. All right. Okay. What about infrastructure? It's projected that within the next 25 to 30 years from today, by 2050 or so, there will be about 1.7 to $3 trillion of damage to infrastructure. That is the cost that we are, and this is in our lifetime, in your lifetime. 25 years. All right. So infrastructure will be, impacted. Local impacts on Long Island, of course, Dr. Gobler alluded to this. Suffolk County flash floods that happened on August 18 last year. I had about 9 inches of rain in my backyard, and water seeped into my basement. I believe some of you might have also got impacted by that. So this is what is going to happen. Drinking water quality, saltwater intrusion in the coastal areas, all of these is going to be impacted with this climate change that we are. This is all local. What about coastal erosion? There'll be a lot of coastal erosion. Fire Island, if you are living close to Fire Island, they'll be very much impacted in the sense that there'll be a lot of erosion going on. So that will also impact the tourism. Okay. What about high temperatures? Last month there was this fire in Pine Barrens. Anybody knows about that? Yes. Yeah, because we had a very warm winter. This winter was very warm. Okay, and so we had this all the conditions right for fire, and that is what we are seeing. We have seen what happened in California, right? So all of these are interrelated to climate. Climate is changing, and we are going to get impacted and get impacted. So what do you do? What are the solutions? Okay, you can do all kinds of things. You will reduce emission. You can buy EVs. You can have hybrids. You can walk. You can bike. You can do all kinds of things. All right. Yeah, or you can do some policy changes like some of the issues like Kyoto Protocol, Paris Treaty, and all those, United Nations programs that is global policy changes. You can do also within there's this proposition of new Green New Deal that was tabled a few years ago. There's all kinds of other things that you can do. You can elect government officials, and you will see them in a few minutes over here. Those people who can be understanding of the gravity of the situation and try to come up with policies that are helpful. All right. Yeah, I mean, there you can have a resiliency brought in. You can start thinking in terms of energy efficiency. You can have community health programs. You can have flood resilience programs set in place. All of these are different measures that you can take, right? Energy resiliency, of course, you can have solar panels, you can have wind energy, geothermal, other alternative energy sources that you can. So NYSERDA and LIPA have this major project off the shore of Long Island on the East Coast, wherein they are supplying 700,000, if I'm not wrong, the houses, the energy coming from these wind farms. So these are all measures that you can think of. All right. So yeah, I mean, like I mentioned, on a local level, you can contribute towards, walking, biking, burning less of fossil fuel, asking your parents to buy, energy efficient appliances, energy efficient vehicles, and things like that. All right, so that leaves us with this question of what you can do, and we'll take help in the last video.
Fighting climate change may feel too daunting for any one person to take on. But a recent report shows that if enough of us change our behaviors and promote change in our communities, we can reduce global greenhouse gas emissions by as much as 37% over the next 3 decades. Here are some of the changes we can make that will have an impact. While individuals can't revolutionize the shipping, flight, and automobile industries overnight, we can make sustainable choices every time we need to go somewhere. Public transportation, carpooling, biking, and walking are all great alternatives when feasible. For a bigger impact, choose a fuel-efficient vehicle when purchasing. Powering your home with solar or wind is still one of the best ways to fight climate change. The good news is that solar panels are becoming increasingly more affordable across the world. Another way to help is to make your next stove, water heater, and furnace purchase electric rather than gas. If these are not feasible options, switching all light bulbs to LEDs, unplugging electronic devices while they aren't in use, washing your clothes in cold water, and cleaning or replacing your HVAC filters every 3 months are small ways to help. After fossil fuels, the food industry, specifically the beef and dairy sectors, is one of the biggest contributors to climate change. If cattle were their own nation, they would be the world's third largest emitter of greenhouse gases after China and the US. You don't have to go vegan or vegetarian to make a difference. Reducing your beef consumption or using dairy alternatives are ways to help reduce this impact. Not only do small actions like these add up, social scientists have found that when one person makes a sustainably oriented decision, other people do too. And as we all know, climate change won't be solved by individual habits alone, but will require broad policy solutions from governments, nonprofits, and industries around the world.
Okay, so that's my spiel here. I believe yeah, there were some technical issues here. I'm a PC person. This is an Apple product. Okay. All right. So now I'd like you to raise your hands and take a pledge. Take a pledge that you will be contributing towards saving this planet. This is the only planet that we have.